right now we have this in here, but we don't have the interaction between A and C. So we would need to take this out and put our interaction between our two independent variables.
Can you do that in the same test or no?
Well, what you'll do is you'll rerun the ANCOVA, and you click on the model tab, and the easiest way is to say, oh, I want a full factorial, and SPSS does it for you.
Okay.
But if you're kind of obsessive like I am, sometimes I insist on doing it myself.
Yeah.
So if at this point the covariates have passed the tests, we can use them. Okay, so example time. What we're going to do is look at the total defects based on the hiring source. And I don't think we've done that yet. We've just been looking at training group for the most part. Hiring source has been ignored except for in the two-factor ANOVA, we looked at hiring source. And so we're going to look at the hiring source total defects relationship by itself, and then we're going to throw in years of experience as a possible covariant. So let me switch to SPSS. And I've got my file here. It's the same one I was using yesterday. And so I have my hiring source over here, and I have my years of experience over here, and then I have training or total defects in its standard spot over here. So I'll just be doing first a standard ANOVA. So I'll go to general linear model, univariate. And what am I going to do first?
A one-way ANOVA?
Yep.
You gotta put your
The univariate will do it for us too, so we'll just do it from here. So we're going to put the dependent variable in, the total defects. And then I want to just do the one-way ANOVA right now, so I put hiring source in for my fixed factor.
Right.
And I'm going to put a couple things in. I'm going to display my means, and I'm going to look at the observed power, just to see what's going on there. And that's all we'll do as far as options. And so now I can run this. And here are the results. Let me slide things around a little bit. We have, for our ANOVA, our focus is hiring source. But first we can look at the corrective model, and the corrective model significance is 0.195. So what's our conclusion about hiring source and total defects based on that significance, or p-value? 0.195. Is hiring source in some way determining that?
No.
It doesn't look like hiring source plays any role in the total defects rate. And we see that with the hiring source variable down here, it has the 0.195 because this is a one-way ANOVA with nothing else in there. And if we look at our means down here, the biggest gap is from 40.9 to 43.4 roughly. So there's a, what would that be, about a 3-point gap, maybe a little bit less than 3 points. So that's with our one-way ANOVA. Now we're going to turn this into an ANCOVA. So we go up here to Analyze, General Linear Model, and we still go to Univariate because we only have one dependent variable. And now we're going to look for years of experience. There it is. And we're going to put it in the covariates box. And I'm going to run this before I test it, just so you can see the results with the covariate in there.
Hold on one second.
Oh, no.
Oh, don't you hate that?
At least it warned me. I have one thing that doesn't warn me. Okay, everyone see what I'm doing here?
Okay.
All I did was add years of experience to the covariance box. And this makes it an ANCOVA, or at least if years of experience is appropriate, it makes it an ANCOVA. So now I run this, and looking at my results, my years of my corrected model has a significance of 0.220. So what does that tell me about my ANCOVA?
You would use the K.
Well, we haven't actually tested it yet. I just ran the ANCOVA before doing the test, like a lot of people are going to do in your dissertation. But so I've got an ANCOVA here with a p-value of 0.220 for the model, and Dino was shaking his head no. Well, 0.220 is not significant. That means that nothing in the model that we're really interested in is going to be significant. So if we look at our hiring source, it's now 0.237, which I think is a larger p-value than before. So this is one of those cases where having that covariate in there actually moved us further away from significance. But if we believe this is an appropriate covariate, that's what we would need to report. That even with the covariate in here, shows this result. So now I'm going to do what you're supposed to do, and I'm going to test that covariate to see if it's appropriate. So we have to go back up to Analyze, General Linear Model, Univariate, and I'm going to do the second test first since I have everything in here to do it, and then I'll go back and do the first test that I talked about. So what I need to do is change my model. And this, I think we looked at the model just briefly earlier, but now I'm going to play around with it. And so what I'm going to do here is I'm going to take it away from being full factorial, which is the default, and I'm going to make a custom model. And you have to be careful when you're doing this because it's not 100% clear at times unless you're used to this interface, what's going to happen. But remember, for our testing the interaction between the fixed factor, hiring source, and years of experience, we need to put that in a model. Well, what we first do is we put main effects for hiring source and years of experience. And so I'm going to select both of those, and even though I can put the interaction in first, I like to do the main effects first. I don't know why. But, so I'm going to change this type in the middle to be main effects. And then I'm going to click the little rightward pointing arrow and put those two in as main effects. Then I'm going to change this to be interaction, select these two variables again, and click to move them over as an interaction. So I'm going to redo this one time so everyone can follow along again. So I'm going to cancel that. So to set up the model, I go into Model, I change from custom, or from full factorial to custom. I put my two main effects in by selecting the variables and then selecting main effects in the little drop-down list and clicking the arrow to add those to my model. Then I want to put my interaction in, so I reselect both of the variables, change my type to interaction, and put that in the model. And if you do this a lot, you can get really good at the shortcut options that SPSS has. I don't do it often enough to be used to those. But for most of the models, it's really easy to do this. You don't have dozens of variables over here. So what I've done is I've set up the custom model, hiring source, years of experience, and then the interaction. And I'll click continue. And now I'll run this. And here are my results. So what do I need to look at? The significance of the interaction. Yep, we need to look at the significance of the interaction. So there's our interaction, and there's our p-value, 0.365. It's not significant, so that means we throw the covariate out.
No.
No. You use
Good,
it.
yeah.
Yeah, you
No,
can use it.
since it's not significant, we keep the covariate.
Okay.
So we've actually done one of the two tests we have to do, and we see it non-significant result. That means that from this test's perspective, the covariate is appropriate. Now we need to do the first test to see if the covariate and the treatment, the independent variable, are in some way related or dependent, or are they independent? So now we have to do this other test. But from this standpoint, since the interaction is not significant, we can keep the covariate in the model. Now, I'll show you the thing I mentioned. Sometimes people forget to correct the model. If we were getting ready to run this for real, we would go up to Analyze, Univariate, go into Model, and the easiest way to correct the model is to just click Full Factorial. And then continue and run this thing, and it's back to the standard ANCOVA model. So when you're correcting the model after running the test, go into Model and just reselect Full Factorial, and then you're good to go. So now we need to do the first test. And so I'm going to go up to Analyze. Once again, General Linear Model, Univariate. We go through that one quite a bit. And then I'm going to reset this so I don't have to worry about all the options I've done. So it's back to its beginning state. And for this test, what I do is my independent variable is still my treatment or my grouping variable. And I was working with what? Hiring source? So I'm going to put that in as my fixed factor. And then my dependent variable is my covariate, years of experience. So I'll put that in. And so that's all I really need to do this test. So I'm going to run this with dependent variable as my covariate and fixed factor is my independent variable. Don't put the covariate, anything in the covariate box. And I'll run this test. And when I look at this for hiring source, we have a p-value less than 0.478. So based on that, is the covariate acceptable?
No.
Dino's saying yes, Steve's saying no. So what do we do about the hypothesis, the null? Do we reject the null based on this?
We failed to reject the null.
Yep, so we fail to reject the null, and the rule is if we fail to reject the null, then the covariate's appropriate. If we were to reject the null, then the covariate's not appropriate. So,
okay.
And that's where you probably can find these summarized in a lot of places, but truthfully I have to look at the slides right before I do this so I remember what those rules are.
All right, this is the second test. I'm thinking.
Yeah, this is
First
testing independence of the covariate.
Independence of the covariate.